light settings in an environment need to be handled with care for maximum user comfort. For example, let's take a reading scenario. A reader needs sufficient light to read comfortably. A smart lighting system refers to a system where multiple luminaries with actuators and light sensors are connected in a network and cooperate. The objective of such a system is to provide adaptive light control that will continuously satisfy users' preferences for any given activity. In a smart lighting system, low-capacity nodes such as wireless sensors and distributed light actuators on the one side, and high-capacity nodes such as mobile handhelds and laptops on the other side may coexist. These low-capacity nodes need to function despite strict constraints on resources such as processing power, memory, storage, energy, bandwidth, and wireless transmission range. In this video, we demonstrate a gateway approach to achieve lightweight smart space functionalities in a network composed of such low-capacity nodes. To do this, we take an existing framework for programming sensor networks, that is OSAS, as the baseline architecture. OSAS stands for the Open Service Architecture for Sensors. It has been developed by Eindhoven University of Technology researchers as a framework for programming networks of very low capacity nodes such as wireless sensors and actuators. It is based on the publish-subscribe communication and on event-based programming. An OSAS network consists of nodes equipped with a specific runtime system. Instead of programming individual nodes one by one, a single piece of program code is employed for the entire network. Sensors and actuators can be reprogrammed over the network by translating the program into a set of configuration messages. An OSAS service generates events through event generators, which are periodically triggered by event condition action rules. A subscription is required to link the event generator of one service to the event handler of another service. The triggering period is specified by subscribers and can differ per subscriber. For each service, the developer indicates by a content-based address under what conditions a node installs and runs that service. This is, in fact, a program for the entire smart space of low-capacity OSAS nodes. The compiler translates the services and subscriptions into instructions to be interpreted by the runtime system on the nodes. The OSAS loader node's task is to upload configuration messages to smart nodes. Now you are looking at the loader interface. The loader sends the content-based address definitions and the compiled services into the sensor actuator network, realizing a dynamic installation. The loader node for the intelligent lighting system demonstrated in this video is called the Light Knowledge Processor, that is, the Light KP. The Light KP is connected with the wireless light sensor network based on the IEEE 802.15.4 protocol. It is also connected with a group of distributed LED luminaries over the USB interface. The light sensors are placed under each luminary, and the light intensity is reported to the Light KP periodically. This information is used to generate light output commands from the Light KP to the actuators of the LED luminaries. In this way, light sensors and actuators cooperate to maintain the light intensity in an activity space according to the user preferences. An event generator at the sensor nodes with intensity in lux to the Light KP via a subscription. The reporting period is determined by the subscription. The user light preference for a given activity is defined as a handler in the sense light service with the minimum and maximum preferred light levels in units of lux. Likewise, the adjust light service is installed in the group of LED actuators to adjust the light output of LED luminaries. As you can see, the developed system is able to achieve and maintain the illumination levels that are preferred by the user in an activity space. When the individual wireless light sensors are under shadow, based on the commands from the light KP, the corresponding actuator and luminary try to increase the illumination in the activity space by increasing the light output. Likewise, when the wireless light sensor readings are too high, based on the commands from the light KP, the corresponding actuator and luminary decrease the illumination in the activity space by dimming down the light output. The system is also resilient against external light variations. When the external light increases or decreases, the light outputs of the LED luminaries are automatically adjusted to appropriate levels. We finalized this video with the expected outcomes before the T18 demo. Semantic interoperability is the ability to automatically interpret the information exchanged meaningfully and accurately in order to provide useful services as required by the end users. In this respect, semantic interoperability across heterogeneous network nodes becomes a key challenge. In the T18 demo, the interoperability of devices with different capacities and seamless integration with the IP infrastructure will be managed by means of the Light KP. The Light KP will not only provide exchange of light model information between low and high capacity nodes of the SOFIA architecture, but also act as an application layer gateway, translating link layer protocols of Smart M3 and OSAS networks, routing packets from one to the other. In the T18 demo, heterogeneous smart lighting system will be demonstrated. The interoperability between the OSAS and the Smart M3 networks is performed by the Light KP, which connects these platforms by using different communication protocols. In this case, the Light KP is a producer KP of the Smart M3 network, as well as the loader node of the OSAS network.